But before we get there, we would like to point out some qualitative observations that we have. The water was very salty-like in its quality. It was oily-like. It was very kind of basic and alkaline to the touch. Bubbles were observed during the process in the plant tank, which indicates that the plant was in fact photosynthesizing and producing oxygen. However, during the duration of the experiment, the plants did appear to have suffered. In the beginning of the experiment, they were greenish in color, their leaves, and during the end, close to the end, they became brownish, possibly indicating that they have suffered during the experiment. When we lifted the plants out of the tank to dispose of them after the experiment, they disintegrated, and we think that this might indicate that they may not have been photosynthesizing properly, not giving their full output during the whole experiment. When we cleared out the jugs, we observed a small sediment of whitish powder on the bottom of each of the jugs, which could indicate that not all of our hydrogen bicarbonate was dissolved. And the pH probe calibrating jars were full of some foreign matter which we could not identify that could have messed with our pH probes when we calibrated them. And so during our experiment, we came over certain thoughts that might give us more ideas what to further investigate. One of the first things was to test multiple plants. We only tested one singular plant in order to see if there are better plants that might handle this job better, or how does this change in carbon dioxide in their water affect every plant, because there might be better plants than the one we used, or some plants might suffer particularly. We could also try different chemical methods, because we only tested one chemical method, and it could be that this method isn't the most efficient, or it isn't the easiest to produce. Also, we only tested the aquatic method. Perhaps we should try and test the aerial method too, because the water method isn't the only method that we could use. As I said, more plants, perhaps take a larger amount of water, because that would allow us to saturate more hydrogen bicarbonate into the water, even more saturating the environment, and perhaps producing a more stark difference between our two filters. Instead of artificially filling our water with hydrogen bicarbonate, we could just take seawater instead from an area where carbon dioxide is more abundant in the water, and see how that would work out. And that way it's more natural and is less likely to harm the plants. And also, before we insert the plants and while we handle the plants, we could use gloves, because the plants are fragile and our touch could have harmed them. And well, here's why we decided to investigate this thing. When we were brainstorming with our group, we decided we wanted to really investigate some sort of serious real life problem. And we came across and we started thinking that, we think about pollution and how carbon dioxide becomes more and more abundant in the atmosphere, producing global warming. We're also thinking how the ocean is a carbon sink for atmospheric carbon, and it lowers the carbon dioxide levels in the air, but it's not an infinite carbon sink, and it may reach a saturation point, and then carbon dioxide from the atmosphere won't be absorbed anymore into the water, and carbon dioxide levels will rise more sharply. And we were thinking, well, maybe we should investigate ways to take carbon dioxide out of the water and store it separately in order to prevent this saturation from happening, because this could also harm other aquatic plants and aquatic life. And so that's how we came across doing this. And we decided that the aquatic method would be better than the air filtering method for several reasons. One, because it would be impossible for us to obtain an apparatus, and to build one ourselves, we looked at many different ways, especially the lithium oxide method, but we did not have materials available for us to build a apparatus that would resist the kind of heat that the lithium oxide method needs. And so hence we decided to take the water filtering method, since we could readily find a carbon dioxide in the water filter. Well, and so then after we did the actual experiment, we decided to do some research and to see which method is actually more feasible. And so we looked at how much would it cost to build us a carbon dioxide filtering plant, that would filter seawater for carbon dioxide and release it with a lowered content of carbon dioxide. And so we found similar plants, and we found out that it would take $737 million to build it, and it would take $449,920,000 to pay for the activated carbon filters at an industrial price for activated carbon. And that amount would produce us 200 million liters of decarbonized water. And so this is a very expensive method, right? But not only that, but it also consumes 6.8 kilowatts per liter. And that's 1.36 billion kilowatts of total power for 200 million liters of decarbonized water. Also, it's not so simple to use because it requires trained personnel to operate such a plant and to make sure that everything goes well, because potentially some harm could be done to the ocean. The method produces extra oxygen. And the power costs, in addition, could also mean that this would accelerate the use of fossil fuels in order to power this plant, and the use of backup generators in case of a power outage. Most likely it would have diesel generators or other ways that fossil fuel could be used in order to power this plant, which would in turn cause more carbon dioxide to enter the atmosphere and in fact counteract the work of the plant. Well, on the other side we have the plants, and a plant like this is under $2. So with the amount of money that it would take to build a carbon dioxide water filtering plant and the operation costs for 200 million liters, not including personnel costs, you would be able to plant 593 million Hygrophila carambosa plants into the ocean. And so that obviously gives you a huge benefit, because not only do you not have to replace the carbon dioxide filters over time, but the plants grow and they reproduce. In fact, they kind of build more carbon dioxide filters if you kind of look at it. And installation costs, the only installation cost there is getting these plants on a boat and giving some people diving suits to go and plant the plants in shallow water. And this method also doesn't require especially heavily trained personnel. And also this method produces oxygen because the plants photosynthesize. However, it does have one major downside, because depending on where you would plant this plant might become invasive, taking over the roles of more native plants and causing other problems, and because it can counteract with local wildlife and cause some harm there. However, mostly, as you can see, the plant method wins and looks like a more feasible method than the activated carbon plant method. Well, on behalf of my group, I'd like to thank you for listening for our presentation. We are very happy to have your attention, and thank you for watching our group for a project.